Quotient function derivative. Example 3, using quotient rule. If you have a function y equals x to the power of n, dy dx equals n x to the power of n minus 1. If you have a quotient function, that means a fraction function, y equals u over v, dy dx is v du dx minus u dv dx divided by v squared. I've got a function here, y equals tan x. But in trigonometry, tan x is also sine of x over cos of x. So this is a fraction function. So therefore, I could say this is u over v. Now, to find the dy dx, remember dy dx can also be called y dot, which can also be called y dash. It can be f dash x. It can be rate of change in y over x, change in x, which sometimes is tangent of an angle theta if you put a value into x and y. And so to find the dy dx here, we can say let u equals sine of x and the u dx equals cos of x. And we say let v equals cos of x, dv dx equals minus sine of x. At the same time, I need to then find the y dx, which means I have to use the quotient rule, because tan of x is sine of x over cos of x. So the y dx will be v du dx minus u dv dx divided by v squared, and that can be equal. V, the v is cos of x, the u dx, and that's the u dx, is also cos of x. That's times cos of x minus u sine of x times dv du, which is minus sine of x, over v squared. And v squared is cos x. So v squared will be cos squared of x. So what we can do now is cos x times cos x is cos squared of x. Minus times minus is plus. Sin x times sin x is sine squared of x over cos squared of x. That will be equal to, we know in trig identity that sine squared of x plus cos squared of x equals 1. So the top bit here will be 1. So that'll be 1 over cos squared of x. We also know in trig that that's 1 over cos of x equals sec x. So this is 1 over cos squared x. So that'll be 1 over cos x squared, which is 1 over cos squared x, and that is sec squared x. Derivative of y equals tan of x, dy dx equals sec squared x. So that's the solution.